Greetings, math fans. All right, I want to talk about just one quick topic here for derivatives. All right, and I want to talk about piecewise functions. And first of all, I want to give you two examples of what a piecewise function can look like and talking about the derivatives. You know, if I have a function that looks like this is a nice negative slope, and then you get a quadratic that looks like this. Okay. First of all, this point right here, this is a relative minimum point. And what is it? Well, some of you might say, well, gee, this the parabola here is going to be a cusp, and the line is going to be a corner. But truly, this is not negative infinity here. This is not like this, where it actually goes to positive infinity, negative infinity. So this actually really is not a cusp. This whole thing is a corner. Okay, because it truly does have a slope at this point right here and at this point right here. You can figure out a slope. One's positive, one's negative, but it is a slope. So that gives us our relative minimum. And of course, we have a relative max up here. Okay, that's pretty easy. And then one other one I want to talk about is if I have a piecewise function that looks like this, and then this one is y equals whatever 3, and then down like this. You might look at this and say, well, gee, it's kind of a maximum right here. But I want you guys to understand this is not a relative max. Okay, for a couple of reasons. One is I want you to think of interval testing, right? If I pick a point here and then I check a point on either side of it, okay, it's not going to be a positive negative slope. So it doesn't actually, it doesn't fulfill the requirements of being a relative max because you're not looking at either side and saying one's positive, one's negative slope. All right, so that is not a relative max. Now, technically, it could be an absolute max, but we're not going to actually say it's a coordinate. We would just say a y value. You would say, oh, what is the absolute max? And if this was, 1, 2, 3, 4, you would say the y value would be y equals 4. Okay, at 4. All right. So I wanted to kind of point those two things out with these problems. All right, so if I give you an example, f of x equals x plus 5 when x is less than 0, and x cubed minus x squared minus 8x plus 5 when x is greater than or equal to 0. Okay, so first of all, what I want to do is I need to make sure it's continuous. So if I check that, I get 0, 5, and this one, if I plug in 0, I get 0, 5. So it is a continuous. It is a continuous function. That's good. Let's investigate each one of these. So f of x equals x plus 5. If I do f prime of x, I get 1. So you guys agree that the slope is positive everywhere. Okay, then let's do this one. F of x equals x cubed minus x squared minus 8x plus 5. So the derivative is 3x squared minus 2x minus 8. Of course, I set that equal to 0. And I factor that. I get 3x plus 4 and x minus 2 equals 0. So my critical points are negative 4/3 and 2. Well, I want you guys to understand that this is not in the domain. Okay? Because look at it. It's when x is greater than or equal to 0, that's that function. So x is equal to negative 4/3 here. So I don't even have to worry about that problem or that point because it's not in the domain. So if I do my interval testing, I'm really just checking 0 and 2. And if I test these values here, well, first of all, this is positive here because it's equal to, the slope is positive everywhere when it's less than 0. Okay, and then I check this one, I get a negative, I'll put a 1 here, and this will be a 3, and this will be positive. Okay, so let's graph this real quickly. This is something like this. If you go 1, 2, 3, 4, 5, and here's the slope, it's negative 1. Or sorry, it's positive 1. And the other graph looks like something like this. Okay, now truly that graph looks like this. Okay, but again, we're not worried about this because that's not in the domain. So that's why I just, sometimes you might look at the problem and go, oh, I've got two critical points, which we did. We had negative 4/3 and 2, but you need to understand those critical points are not necessarily in the domain, and this one, we didn't have to worry about it. We only had to worry about this one. So we have 2 points here, and just kind of go back here. Our relative max, of course, is going from positive to negative, so relative max is 0, 5. And our relative minimum point going from this negative to a positive is going to be 2, negative 7. Okay? So just want to do one quick piecewise function with you, just kind of show you how it works with with relative extrema. All right? That's it, math fans. Adios. Goodbye.